possibly would
It runs it pretty good. But the only problem is when you got to run 4 inches. When you only got a 4-inch piece, this little jewel right here, it holds the metal really sweet. And it'll do just like when I've got them filter racks out, I may only have 1 inch of Pittsburgh minus.
So you say on shorter pieces, this thing works better.
Yeah, because like I said, if I've only got 1 inch of Pittsburgh, then I had to cut out 1.25 inches for a filter rack, and then I have another inch of Pittsburgh, and then I'm going to bend it up here. So you basically got 1 inch, 1 inch, 1 inch, and that thing will run that 1 inch like it was running 12 inches. It just holds it real tight.
the other end here. Just as soon as you get through doing what you're doing.
So this is how it comes, and you will cut
I'll cut about a quarter or a half.
Otherwise, you won't be able to fit the corner in there.
Well, you can, but you have to beat it in there with a hammer.
Yeah. And so
then on this
the other
side,
side you cut already.
That's the side I cut. And when I go to put a corner in there, I can take my hand and just slip it right in there.
And,
So this is a flange, like he was turning on that power edger up there. And this, like I said, this is going on radius piece. And then run that female thing. They want to watch it. So they'll start at one end or the other. Get it started in. And he's gone through and he's opened that lock up a little bit. And now he's doing what we call tacking the fitting together.
And realistically, at first I thought being welded was easier because it's just one fitting, but you're not fighting with it if it's a little left, a little right.
Exactly.
You put it in, they screw, and the screw itself centers it, and that's it. I thought it was easy. At first I was like, oh, it's just one piece, put it on. But then I spoke to him, and like he said, you got to center it. Where this one, you put the outside, you put the inside, and the screw itself centers it.
You can move the inside.
Well, the inside closes a little bit. You close it, put it in, and then you screw from one side to the other, and it centers itself.
because it's split right there.
Yeah, it's split here, so you can close it, throw it in, and then you just start screwing.
But the outer being welded is okay.
Yeah, the outer being welded is fine. But the outer being welded, if the outer being welded, you don't need to center anything. What you gotta center is the inside.
So this
It's a pretty big cheek for an easy edge. That power flanger would have saved you some money on this one if you had to do this by hand.
Yep, 20 gauge, had to do it by hand.
That little corner, so you take it in there, bend it over. See, Jim Paul made this
Oh yeah.
when they get real big. Slide that little dude right there out.
Because the edger is because of the work table, the space.
You got a whole
Do it out in the field?
Yeah,
You like doing it here better?
I like working in the shop more than I like working in the field. The field is tough, man. It's hard on you.
Yeah.
Up and down stairs all day, up and down
And
ladders.
you gotta
The
dodge
conditions-
everyone else.
The conditions are never great.
Yeah.
You know, I mean, last time I was out in the field, I slipped on some water because the stuff is crazy, inflation, and that tweaked my back all out. So it's just, I like the shop. It's more, you know what you're getting into pretty much every day.
If you couldn't make it in one piece, would you?
Makes too much metal. You waste quite a bit of metal on a sheet when you do that because it rounds it out so much.
Okay.
So when you do two-piece, it's a lot smaller. You save a lot of metal that way.
I never thought about that way, yeah. So you're saying the metal cut would not be that good?
It would
Drop?
It would round, yeah, the drop. They'd leave a lot of drop.
That makes sense though. Learn something new every day. What about inspectors who, unless they see a mastic on the outside, they don't?
They don't know. Other than you have to pressure test it.
Okay, so
You put a vacuum cleaner on one end of it.
okay.
And you ring of pressure, you do the whole line. You capture one end of it, and you put the vacuum cleaner on the other line, and you create pressure, and it's got a gauge on there and water gauge, and they check it. So if it's got leaks, it's to your advantage to have it sealed before you put it up.
Yeah. So nesting is the same as optimization.
Yeah, it just nests it together to configure how it's going to cut it out of the sheet instead of putting all of this fitting in all of this one and having big pieces of drop right here for it to fit to optimize the sheet of metal.
Okay.
Years ago.
Is that a pretty easy change?
Oh yeah. That just
Push that out. It goes from a quarter to 7/16.
So that's a VAV box?
That's the line. The VAV box is actually.
What are you, how are you making this right here?
Our handbrake.
we don't have a fancy swing around brake that everybody keeps raving about. What? Then put it in there and pull the handle out. Tighter radius. Bring it out.
That's a lot of bends to make this right here.
Oh wait, you don't even need to put on the machine now. Good.
The oval dimension's really only critical for the minor axis. The major axis no one cares about. They just have the ceiling height. That's why it comes into play, right?
Right.
So if someone comes in and gives them a list or a drawing that's got, say, 20 by 40 duct on there for 30 feet,
Yeah.
what they're going to do is provide 80 by 40 or 18 by 42 oval rather than 20 by 40.
Okay.
They're just going to stretch the major by the equivalent round, right?
Okay. What was the issue with this now?
This right here sticks a lot better than the type I had.
Okay. Here's a good view of the opening roll right there.
Well, that's a nice thing to have. I wish they made them thick.
If you're fitting up against that, clamp it down so it'll hold it all the way down through there.
If you don't have it on there, the metal starts pulling out this way.
Yeah, it just seems to kick it out and wobble it because there's only one roll touching it.
You turn that on and this becomes a magnet?
Yeah. Press this button and you start picking the handle up, you hear it starting to buzz,
Yeah.
you turn the magnet on. See, there it's off. You see, it don't come on, but if you press the button and pick it up, it starts energizing it.
You have to press that button every time?
Yeah, when you go to pick it up.
What
What
type of things do you make from this?
Oh, we bend all kinds of stuff, like stop ends and pans. We'll bend the hem, the whole pan, bend the two long sides, and put it on here and do the short.
How far is that water coming out?
That is at 20,000 psi. And it's a velocity of 3,000 feet per second or something.
Obviously, the sprinkler fitter can't go there.
So that's the sprinkler fitter right there?
Yeah, it's his line running across. Can't do that.
And what is
This is vent. That's the cable tray. Fire sprinkler pipe.
What's the cable tray?
All the data cabling. This is chill water supply, chill water return, hot water supply, hot water return. Domestic hot water, domestic cold. He hasn't put the insulation on it yet. But
And that's the duct hanging above it?
mm-hmm.
When the strut and the, or the angle and the
Yeah, you know, your hangers
hangers.
shows everything.
It's a lot of offsets.
Yeah, I have to have 5,000 offsets in my ductwork just to make everything fit.
What would you do without this system? Just, you wouldn't find out anything until you got to the job?
Yeah, you make it work in the field.
Is that enough of a plan?
order, but it's actually big.
I know it looks like it takes a lot of practice to get used to it.
Don't look at his flames.
So you adjust.
Well, this is what they call a tungsten little round stop, and by moving this back and forward, you can change the throats you go further back, the heels you come up.
Okay. So could you tell me that again?
Okay, so return air comes in through here, right, and then actually gets exhausted back out again. Okay.
What is that copper pipe? Is that plumbing or is it?
It's plumbing.
Okay.
Yeah.
Oh yeah. So you have to cut a skeleton sort of.
Like that.
Yeah, that makes sense. You want to run a piece there? I think, yeah, it's the very bottom.
Then you wouldn't have to go to the sheet bender.
Oh yeah.
Yeah. I owe you, man.
You call that a T-connection or a
Outside tap.
outside tap? Okay.
Tap in the side of the duct. Cut your hole, stick it in, and then the flange is over, and then you come out with your brand.
Do you use any of the other two?
I do not. I think
If you have a scrap piece that you can run through the bottom,
it'll make it short.
you'll do the male Pittsburgh, I believe.
Run a large Pittsburgh.
Yeah, okay. That means you wouldn't have to break it on the brake. This thing right here. This one is like right at 53.
Oh, is that the cheek turner? Oh yeah, that.
Yeah.
Oh, that's I see. Yeah, that's nice. I haven't seen that one.
Yeah. You try it for a month, you won't ever.
What is the price on this?
53.
53?
Yeah, we just need to get one of those. To be honest with you, put that on the bill with the king slitter, not the king slitter, the slitter.
Okay.
You want it?
Yeah, definitely. Just look
All right.
how easy.
If you wanted to, are you able to like pull and just show your product? Yeah, like what you're doing? Remove.
Meaning like just show the duct work.
Yeah, yeah.
That's down in the basement.
Okay. Big air handlers.
And y'all do all y'all's own piping in house, right?
Yep.
What's the light blue?
This is your main supply line,
Okay.
and then the dark blue is after your VAV pot.
So all the light blue is all medium pressure,
Yeah,
and all the dark blue is all low pressure.
that's right.
I got you.
Your drop on line fittings is just about negligible.
Yeah, it'll mess it all in there.
What's the speed?
990 a minute. 990 inches a minute. It never really gets up to that, you know, but it's trying to ramp up to that. Now, if you had a big, long piece of cutting, it gets up. It's increasing speed as it's going.
Can you get an additional table?
Oh yeah, oh yeah.
You can make it in 5x20?
Oh, it's definitely lots of them. Yeah.
940 inches a minute?
How much? That's a plasma around about 400, 500.
400, yeah.
400, 500.
Yeah.
Now, 24 gig? Oh, yeah.
So this is actually, you're feeding this from your main coil line.
You don't have a coil line, you don't need a 20-foot cable, but if you got a coil line, you need a 20-foot cable.
This on your duct or your turn is actually greater in the turn. You have more inches here than you do across here. So when you stack your turning vanes from the throat all the way to the back there in that corner, you actually have more turning surface for the air to go around.
So on this elbow right here, you made the elbow, and then you measured
from the throat
to the point of the heel to determine how
many vanes go in there.
And we can take the shearing bin and make it a full coil line.
Okay.
We can do that, but there's a couple of things to consider. I mean, if you add that on down, then you're still going to turn the male flange of the Pittsburgh with the brake, and then we'll just run it through a female roll former, and then we go down. But you can't. Here's the thing: you still have to buy another brake
for the end.
For the end.
Yeah.
Because for the TVC and whatnot. So you've got two brakes here. The machine's going to have to stop to brake the male flange, and then when it gets to the other end, it's got to stop to brake it into L or full wrap.
Okay, for the button punch, it'll punch it.
Is it a good strong notch there? It's not just a dimple.
Yeah, it's got a bit to where it does stick out to where it'll bite into it.
Okay.
We'll do that, both of them, and then put it in the top, and it'll bend it to the 7/16.
Yeah, okay. So in other words, this machine's not just for square elbows, it's for all types of fittings.
Anything.
Yeah. Because generally all fittings except for cut joints are going to be 4-piece, right?
Yeah, a normal transition will be 4-piece. Let me grab the hand on, straighten these ends out.
Large female Pittsburgh, and a lot of shops will use the standard button lock to mate with the large female Pittsburgh.